And welcome to Rural Delivery. This week we spend time with Plant and Food Research's bee expert, Dr. Mark Goodwin, who's conducting research into the role of gut-dwelling parasites in unexplained bee deaths. We visit the dairy farm of Rex Butterworth, who's invested in a new farm system and is reaping the rewards, both environmentally and economically. And we find out why soil matters and the growing interest in understanding more about the soil and its effect on agricultural productivity. Unexplained bee deaths in the spring of 2014 all but wiped out thousands of hives in the Coromandel, Raglan and Wairarapa areas. Dr. Mark Goodwin from the Honeybee and Pollination Research Team at Plant and Food Research is trying to determine the role of 3 gut-dwelling parasites in the bee deaths.
We got a phone call last spring from a beekeeper in the Coromandel Peninsula who reported that a large number of their colonies were dying. And the symptoms they described to us were symptoms we hadn't heard of. So we went up and had a look at them, and they were certainly new to us as well. What started with colonies in the spring with about 15 or 20,000 bees, which would normally grow up to be really big colonies and produce honey, when the beekeeper came back about a month later, all there was a queen and about 200 bees. And it's not just one colony, we're talking hundreds and possibly thousands of colonies. We organised a big beekeeper meeting in the Coromandel to find out how many people were affected. And when they turned up, there was a whole lot more who had losses who we didn't know about because they assumed it was something they'd done rather than something more generic. The symptoms look like what we see overseas that are loosely described as colony collapse disorder, which is a problem in Europe and through the US. Just because the symptoms look like it doesn't mean that's what the cause is though. When we tested the bees, they had very high levels of a couple of gut parasites. Nosema apis, which is a microsporidium parasite, which has been in New Zealand forever, and it's very hard to associate it with these symptoms. But we do have a new one that was first found in New Zealand in about 2006. It's Nosema serrana, and it's an organism that a jumped species from an Asian species of honeybee, the same place Varroa came from. They also have Lotmeria, which is another well, we don't even know if it's a pathogen. It's a new record for New Zealand being present here, but it may be just that we've never looked before, and it may have been forever as well. And we know that these things are in very high levels, and we know for Nosema apis and Nosema serrana, at least, high levels usually mean bad things for colonies. Whether it's the cause of everything we're seeing here, we just don't know yet. Lots of things have been suggested to be the cause, ranging from cell phones, through to neonicotinoids, through to pollen shortage, through to pathogens. In fact, everything you can imagine has been suggested as a cause for it. In reality, we don't know. When we started the work, there was a few things we could exclude straight away. A lot of the world has pointed towards a class of chemical neonicotinoids as a potential cause for colony collapse disorder. But we're working in the Coromandel, which is mainly regenerating forest. There's not a lot of chemical use at all. So it was very unlikely that that was the cause. When we're looking for hypotheses to explain why these colonies have all these gut parasites suddenly, there is something else, of course, that's happening out there with bees in New Zealand, and that since 2006, we've doubled the hive numbers in the country. We've gone from 260,000 colonies to 500,000 colonies. And they've been put mostly into very high stocking rates on Manuka. So we've got densities of bees that we've just never seen before. Whether this has some relationship with what we're starting to see at the moment, we don't know. The symptoms are in places where we do have high densities. We can't conclude from that that's the cause, but it does point us in a direction that we certainly going to look at. And particularly what happened last autumn about food availability, whether they will have enough pollen going into the winter because of this competition, is a question that is sitting out there to be answered. We've just started with these samples of bees that we know have got high levels of disease. We know nothing else about those bees other than what hives they came from. And the bees that left the hive, we can't even sample. So what we need is colonies with bees that we can track, that we know when they were born, we know how long they've been in the hive, and we can sample at different times to work out their disease loadings, whether they leave or not, and whether it's affected their lifespan. And that's what the marking of the bees are. So we can have a lot of colonies with bees that we can actually recognise. We take frames out of a colony, shake all the bees off and put it into an incubator. And then every day new bees will emerge from the colony. We can pick those off and we can mark them. Really great thing about using cold-blooded animals like bees is if you cool them, they stop moving. So we put them in a fridge for a few minutes, they stop moving, we can paint them and warm them up again, and they just carry on as normal. They're great to work with for two reasons. One is they don't sting you, but a second one is we know they don't have any other diseases. They emerge almost as a clean slate. So any diseases they get now, they'll get from the colonies we put them in. So when we come back and sample them, we can know a lot about the colony we've put them in and their history in there to do the testing. Worldwide, there is one treatment available for nosema, and it's fumagillin. However, it's banned in a lot of countries because of the residues and the product that it is. It's not allowed in New Zealand, and it's not allowed in Australia. And so we actually don't have anything present at this point in time that we know will definitely work against nosema. There are some organic products that have some claims that way, but it's really only guessed to see whether it's an effect. So that's one question we're having to go through now, is the permission to, one, get to use it for experimental purpose, but then the industry is going to have to answer the question, assuming Nosema cerana is the issue here, do they want to have a chemical treatment that they can use? Planted Food has put some of their core funding into this problem, and we're just talking to all the people in New Zealand who actually use bees, either to produce honey or to do pollination, to come in for co-funding to help fund the project. Regardless of all of that, we've started investigating it, and we'll just assume that the rest of the funding we need will turn up to actually finish the project. It will be really interesting for us as researchers and for the regulators who are keeping an eye on things that are happening if beekeepers do report where they have losses. And there are a number of ways of doing that. The Environmental Protection Agency has a website that you can report directly onto. Secondly, beekeepers can report through the National Society. And also the National Society can arrange from a commercial lab in the Hawke's Bay to get samples tested, which the results come back to us as well, which is very handy. So again, part of the research question is looking at hives individually, but also get a feel overall what's happening. And that sort of reporting is actually very useful.
After the break, we meet dairy farmer Rex Butterworth, who's a strong advocate for adopting new technology. Welcome back. Rex Butterworth is a farmer in Waikato who's dealing with all the common challenges of dairying in New Zealand today. But he believes he's found a system that's doing very good business for him and his herd. Rex has been working with agribusiness consultant Alison.
It's really important for any farmer to find out where they're at before they take a step forward into any sort of different farm system. So what we started with Rex was really understanding how his farm had been performing in the previous couple of years. So you need to get a baseline, and then from there you start extrapolating forward and look at a range of different systems, of which the situation was going to require quite a bit of investment and what it was going to do to the risk profile of the business. A key part of this is to understand what the farmer's values are. So in this situation, what did Rex really want to do? And he wanted improved efficiency, lower risk and more profit, and certainly a bang for the buck. But also a key here is long term, is it going to be low risk, and is it going to keep his farm system ahead of the game? Right across New Zealand, there's probably 50% of New Zealand has got some nutrient rules in place. Waikato's due to announce their rules next year. In Rex's situation, I think with nitrogen leaching, for example, was sitting at about the industry average at about 40 kilos of N per hectare. With the implementation of this system and better management out on the farm, it's down to half now, so leaching about 20 kilos of nitrogen per hectare. And so whatever happens with the rules in terms of phosphorus management, nitrogen management, sediment and pathogens, this farm system's really well placed for the future. We've got 4.3 cows to the hectare on this farm, but in reality, nitrogen leaching's linked to urine patch out in the paddock. So if we've got these cows in a situation where we can capture the effluent and then use that at the optimal times of year, then we can overcome that problem. So high stocking rate, we've got really high performance. These cows are sitting at about 93% of their body weight as milk solids, which is excellent. I mean, the rest of the industry is sitting at high 70s to 80. A whole lot of things coming together with good management really help this business to be very efficient. There's going to be two ways to go. Farmers will either have the choice of sort of winding back their systems to be lower impact, or grabbing all the efficiencies with excellent management, such as these sort of farm systems, and capitalising on that. So in this situation, we've got really high levels of efficiency, so almost double the production per hectare with half the leaching. So that's such a great story. And in this situation, we've got about 95 kilos of milk solids per kilo of nitrogen leached, which is a hugely efficient, productive system with a low impact. Now, if we look at the average across New Zealand, it's sitting at about 20 kilos of milk solids per kilo of N leach. So this is 4 times as efficient as what we see in, say, irrigated Canterbury.
So I've got the
data sheet, just
the data sheet, and I've only started just pulling it in.
Yeah, no, that'd be so awesome.
After I'd looked at all of the different options, the herd home pretty much covered all the bases, and so we built one to see how it would go. You know, the quite significant investment, and we weren't sure whether we could justify having 2 or whether we could make do with 1. But after a short period of having the first one up and running, we realised to get the true benefits we needed both. We can't control the weather, but now we do have a lot of control over the effects of the weather. We had a fairly low cost of production before the herd homes, but the amount of income varied a lot with climatic changes, and that made it really hard to budget. Plus the cows would suffer because we couldn't look after them as well as we should. So it's taken a lot of the risk out of the business, and we're bar having irrigation, we're probably as in control as we could be. The use of the home, it varies from winter to summer. The calving cows come in here during bad nights. We've got the lights, so it's easy enough to check them. Then during the summer, they're in here whenever it's like from about 10:30, 11 o'clock in the morning. They come in when it gets a little bit too hot and they've stopped eating and drinking in the paddocks. They come in here and enjoy the shade, eat and drink all day, and go back out after the evening milking when it's cooler. During the winter, we can bring them in here. They're warm, so basically anything they're eating is going towards weight gain or maintaining their condition score already. If there's any sign of any pugging, we take them off before that's likely to happen. There's no point in taking them off once it's happened, so we preempt it, and if we know that it's going to rain in half an hour's time, we pull them off. So basically, if we end up with pugging, we haven't done our job properly. So the farm's fairly basic. Our inputs are grass silage made on the runoff, maize grown on the runoff, and PKE, that's in there only to fill the gaps. We try not to rely too heavily on it, although in the last 2 years we've had to because of the severe droughts. Every year we grow more maize, every year we seem to need more feed, so we're still chasing the 8 ball a little bit, but there's no other feed going in other than that. The biggest challenge that we found with it is pasture management. We were pretty good with it beforehand, but now that the cows have become better fed and less tolerant of the weather conditions, we've got to be very, very careful that we don't waste grass, and so making sure pasture utilisation is as good as it can be is the thing that we struggled with more than anything. The payout being as low as it is, it's certainly hurting us, there's no doubt about that. If we didn't have the herd homes, we'd be in a far worse position than we are. We've been able to control our costs because of our new system, and we are one of the few farms that are still profitable in a payout like this, but we're not making very much money. We've got our heads above water, but at least we're not going backwards.
We'll be back soon in North Canterbury to meet soil consultant Rob Flynn, who's been working with farmers in the region, including Tim Wilding at Taimania Angus Stud. Hello again. Biological farming is a term used to describe a system that focuses on improving soil health by fostering the health of soil microorganisms. Rob Flynn is a soil consultant who helps farmers address any shortcomings in the soil. Rob also owns a lime works and, along with others, has built a business importing fertilisers and producing mixes to suit the needs of farmers taking a biological approach to their farm management.
Well, the business is a lime works, which we bought 15 years ago. I could just see a need for lime. This is a very good quality lime. Also, everyone's very conscious of pH and whatnot, so there's one way to shift your pH is through lime. We've expanded with the Soil Matters consultancy side of it. We do soil testing, make recommendations for pastures, crops, whatever, and then we mix our brews to whatever is required to make the soil right. And generally most things we can mix. Some things have to go on separately. We're a certified BioGrow mixing site, which gives us the flexibility of dealing with everyone.
7.
My main driver is that if you do something, you want to do it for the good of everyone and everything. My view on acidic fertilisers are when we're trying to make our soils alkaline, the big focus on pH, which is alkaline, why do we keep pouring on acidic fertilisers? So that is, I know acidic fertilisers are generally more water soluble. That again leads to runoff and the conditions that we're experiencing now, and why we have overseer and everything else, is we're measuring these things. The science around biological farming is all there. It's just a lot broader than putting X on to get Y. There's a lot of other factors in farming as in animal health and everything else. It's not just about dry matter. And there's more than enough science around there. And I think a lot of the art of farming is being lost. It's more textbook and without observation. The biggest thing with biological farming, and when we take on new clients and they have this realisation that there's actually something underneath them, and they start being more observant, and then they observe their stock and health and everything else. The difference between biological and organic farming, the principles are the same in that you look at the whole picture, but definitely not. I do believe organic farmers do not concentrate enough on inputs because basically they don't know that they can actually use these inputs. We work with nature, if you like, or gravity, and it comes off the top of the hill, works its way down, goes through a jaw crusher or a primary crusher and brings it down to a uniform size, and then goes into the hammer mill, which ends up with your lime flour. So the whole system's on gravity, and the trucks are fed out at the bottom end. And then from there we have all different bins with our elements in to mix as we go. The mixes are made as needed, not preset. It is a recipe, and you've got to be very careful because you're using the farmer's money, and it's got to work. And apart from that, when you get your elements up, we make another soil conditioner called Zoom, which then, if your biology's struggling, this helps to get your biology humming again.
Over the last 10 years, we've developed a bit of a fascination, I guess, around looking at alternate ways of treating and fertilising our pastures and crops and things. It makes a lot of sense that if you can put less acidic-based sort of type fertilisers and fossil fuel reliance fertilisers on your paddocks, it's probably got to be good for everybody. Rob at Soil Matters approached us about trialling a couple of paddocks at Tamania, and we put those under a biological regime for about 2 years when we'd sort of had pretty limited results with doing conventional superphosphate and type applications. And over that time we definitely got a turnaround in the whole soil structure and the worm life and things, so that sort of led us to do it over the whole property, and we've sort of never looked back. We haven't used any nitrogen-based fertilisers or acidic-based fertilisers for nearly 8 to 10 years now. We've found that under a biological system, there is definitely a marked improvement in stock health. I mean, scientifically, how we can quantify that number, I'm not sure, but we've had feedback from clients buying bulls and things that the bulls seem to be a lot quieter and I'm sure that's something to do with, if you feed them, they're on a high acidic based pasture, superphosphate and things, it certainly seems to stir things up compared with coming off these type of pastures, and we've had reasonable comment from buyers about that. There's always going to be a need for more science and research around these things, and we started to do some work. We did a few tests with the ESR around beef sampling and omega-3 in beef, and getting quite a considerable difference in omega-3 off the biologically farmed pastures. The feedback we've had with their Angus program with Countdown is that they see that there was a good demand for healthy, nutritious food, and they were very supportive with our PGP application around trying to help develop that. But it's like anything, I think to get more uptake of biological farming, it's really got to be consumer driven, and so to do that we've really got to start getting some retail product happening that's certified biologically grown, and hopefully part of our PGP application was to identify and show that it had a better nutritional profile, and I think that's sort of what we're going to have to do with retail packaging and things.
If you'd like more information about these or any stories we've covered, you can visit our website. Get there via tvnz.co.nz. You can also watch any episodes you might have missed on TVNZ On Demand using the keyword Rural Delivery. Next week, we look at the early development of a robot designed to make forestry harvesting and management safer. We learn about the business of Blueberry Country, New Zealand's largest blueberry growing business. And we hear how Greg and Alison Furness from Blueberry Country pioneered development of machinery for sorting and grading soft fruit that's now a high-tech fruit handling company. Thanks for joining us today. We hope to see you again next time. This program was made with funding from New Zealand On Air.